Hello, and thank you for joining us today in our fantastic webinar entitled How to Add Floor Heating to New Wood Floors. My name is Scott.
And my name is Anatoly.
And we're from the WarmlyYours Technical Support Department. So we'd like to thank you for coming along today. And we value your attendance today. If you have any questions along the way, just look at that white box on the left side of your screen right there in the middle. And that's where you type in your questions. And we've got quite a few questions already that were submitted before the video, and we'll be addressing those a little bit later. So let's talk about electric radiant heating and wood floors. Anatoly, tell us a little bit more about this subject.
So first of all, with the proper care, wood floors can last for many years. That's a great choice of flooring. Also, investing in electric floor heating allows you to add another level of comfort to your home. For those who also suffer from allergies, adding the floor heating to your home cuts down on dust and allergens and just provides a very healthy form of heating.
One thing I would like to add to that, and I'm the guy that typed this last one in because it's a very important one that no one ever really talks about. And the one thing is, no matter if you put a wood floor in, no matter if there's electric heating under it or not, the thing you need to do is that you need to follow the rules that the manufacturer sets about keeping the relative humidity within a certain specified range. If it's 30 to 60, if it's 25 to 50, whatever it is, whether there's heat under it or not, you need to follow those relative humidity requirements. In the summertime, wood swells. When it's high humidity, it does this. And then in the wintertime, when you have a lot of forced air heat going on, it does this. It separates because it shrinks. It expands and contracts depending on the relative humidity. So in the summertime, you might need to use a dehumidifier. And in the wintertime in the Midwest, I can tell you from personal experience, is you do need to use a humidifier to keep it in that range. That's very, very important. We have a question. Oh, this is a great point too. How does the floor heat cut down on dust and allergens?
Definitely a great question. Yeah, radiant heat really does not move your air a lot, so you don't have any forced air running, which means your house, your room, heats up by the radiant heat. So there is really no air movement involved at all.
That's a great question. And it reminds me, I just got this message on my thermostat today that my filter is due for replacement. So that's why this is very, very important. There is no forced air blowing dust and stuff around. And if you're bad like me, sometimes I forget to change my filter, then you have a lot of dust being blown around. With radiant heat, you have none of that. So it's a great question. Thank you so much for submitting that. So let's talk about the different kinds of woods that we're going to cover today.
Right. So today we will be talking about three main types of wood flooring. That will be an engineered wood with a floating type of installation, a glue-down engineered wood flooring, and a nail-down hardwood.
Now you can see we're not talking about laminate here because laminate is really only made of a particle board and a plastic layer on the top, silica-based topping on it. Depends on what kind you buy. But really the only wood in laminate is just crunched up wood and particle board. So we're really not talking about that application today. We're talking about engineered wood. Now, what's the difference between engineered wood and nailed down wood?
So with a nailed down wood, we're talking about a real wood flooring that will be attached to your subfloor by simply nailing that down. So there is no adhesive typically involved, and it's just that mechanical way of securing the wood to the subfloor.
Engineered wood just has a layer of wood on top that's covered with a wear layer. Most of it then is not, this beautiful flooring. It's only on the very, very top layer. So engineered wood is a completely different beast than nailed down hardwood. Nailed down hardwood is usually about 3/4 of an inch thick, and it is, as you said, a solid hardwood product. So let's talk about the different ways of heating the electric, doing the electric heating in these rooms.
Sure. So first of all, those two products that you see on the very top of the slide, that's Environ products, the cut and turn roll on the left and the Easy Mat on the right, which we will be talking about. That's your best product for the floating application, for the floating wood flooring. And then the TempZone products, the one that are at the bottom of the slide, the TempZone Flex Roll and the TempZone Cable, these are the products that would need to be embedded in self-leveling cement. And then later on, you can do your glue down or nail down wood floorings.
So the stuff on the top is stuff that's designed to float. It's not attached to anything, and nothing is really attached to it. The products at the bottom are temp zone products, and they must be covered with a non-combustible medium like self-leveling or thin set. Obviously, self-leveling is the best thing to use because it gives you a nice flat floor that you can put this product over. So what do we need to do to get started?
So really, just to get started, to get a nice plan or quotation from us, what we really need is just a sketch of the area where the floor heating needs to be added, or maybe marked up area of a specific heated area that needs to be covered with a floor heating element. And all that would be left to do is just send that information to sales@warmlyyours.com with just basic information of what subfloor you have and what type of flooring you will be using from the types that we just discussed. And if you know, or your electrician provided that information to you, we would be glad to know that desired voltage so we can quote the right product for you.
Also, you need to let us know if there's any permanent fixtures that are going to be laying above the flooring, because we do not go over, you never heat under permanent fixtures. And also, if you notice in this drawing has one problem that we would send back to you and ask for more information, and that is I don't see any floor vents drawn on this drawing. So we need to know where floor vents are because you can't install the heating over the top of floor vents. So it's very important that you just sketch this out, give us the dimensions, take a picture of it with your cell phone, email it to sales@warmlyyours.com, and then we'll take a look at it and get you that plan. The great thing about the plan is instead of making you figure out, okay, here's your roll, now go ahead and try to figure out how to put it in, we actually say, here's your roll and here's how it's laid out in the room to make it fit. So that's what's so great about this. You don't have to figure it out. Our engineers will figure it out for you. What do we need to do first?
Testing is, I would say, the most important part of the whole installation here because you want to make sure that the heating system is tested and you install in a system that is fully functioning and don't have any problems. So testing the system with a multimeter, digital multimeter, is a great step before, during, and after the installation.
If you are going to be installing floors on a regular basis, you need to invest the $19.99 into that digital voltmeter. So we have a question here from Chris, and Chris, we are going to address your question specifically a little bit later. Thank you for sending that in, but we've already had a few people ask that question and we're going to address it. So thank you for sending that. The circuit chip is not a troubleshooting device, but it's used to tell you if any of the wires get damaged while you're installing it. It'll scream at you. It'll say, please stop, because what you just did to make the siren go off, maybe drop your hammer, drop a saw or something like that. It'll tell you to stop right there and give us a call. The secret to the first test is to not wait until you are out on the job site in the morning, ready to go install the product and test it the first time then. You should really test it as soon as you get the product in the box. Because that way, if there's a problem with the product that you get, something happened, it dropped out of the airplane, and they picked it up and said, okay, it looks great, but it tests bad, give us a call. That way we can get you out a new product before it's time to go out there on the job site. So let's talk about floating engineered wood. So what are the differences here?
Yeah, so here's your typical cross-section for an engineered floating application. And everything starts here, of course, with a plywood subfloor. Then we want to add a layer of an underlayment. In our case, we offer a cork underlayment, which is 1/4 of an inch thick and acts as a thermal break as well and goes right over that plywood subfloor. Then, as you can see, the second layer would be an environ heating mat. And this configuration on this cross-section, it's an actual flex roll, the one that can be modified into a custom floor plan that you need. And since the whole application is fully floating, then you just adding your floating wood flooring on top of it.
If we take a look at this slide, we get this question all the time. Can I get that really, really cheap underlayment that comes on a roll that's blue and it's about 1/16 of an inch thick? The answer to that is probably not a good match for this product because the cables that come out of the heating product are about 1/4 of an inch thick. Okay, so if you're using a product that's only 1/8 or 1/16 of an inch thick as padding, that means with a wood subfloor, you're going to have to take a router and route a route for that cable to get from the heating mat over to the wall. So the thing is, if you use cork, the cork is the same thickness. So all you have to do is channel out the cork and the cable runs right in there. You don't feel any teeter-totter over the top. So we can't suggest strongly enough that you don't use that real thin, foamy type product. Get a cork underlayment because it has a good R value and it gives you that 1/4 of an inch to get the cables back to the wall. Okay, I have a question from Mary about on a slab foundation. How do you make the transition between a carpeted area and a room now getting this system? Well, they have lots of different transitions. I installed this at a customer's house, and there is a small 1/4 inch transition to go from one room to the next. And I've been over there a few times. I've never stubbed my toe. It's really just like going from carpeting to laminate or whatever. There's going to be a slight difference.
Sure.
But there's no way you're not going to go in and take the subfloor out and lower everything to make it fit in there. There are transitions made specifically, especially if you're going to the wood floor from another wood floor. It may be 1/8 of an inch higher. They've got transitions for all that stuff.
I think what we can just add here is that our cork underlayment is 1/4 of an inch thick, and the heating product, the Environ heating mat, is typically is just 1/8 of an inch thick.
Or what, 1/16 at the most.
Yeah,
because anywhere between there. Yeah, so that's, sorry I interrupted, but I feel very strongly about this. So if you're thinking about putting the underlayment, remember, the underlayment goes between the plywood subfloor and the mat. The mat is never placed between two hard surfaces because there's a wire running in between there, and you don't want this motion. One surface has to be soft and one is hard. So you want the underlayment to be under the heating product, and you don't want another product, another underlayment, to go over the top of the heat because that's going to keep the heat from going up into the floor. So this way is the perfect way to install the floor. We get this question all the time, as you can tell, so I just want to make sure that we discuss this fully. Let's talk a little bit more about cork.
So yeah, cork is the main benefit that I would also mention about the cork is, of course, the increasing efficiency. So with adding the cork, we adding about 0.72 R value beneath the product, which means we're creating that thermal break. Also, we recommend to install it in that nice staggered brick-like pattern, so you can still secure that down. And for the install, sheets are attached to each other, but not to the floor. In other words, we're still trying to get that floating feel, floating application throughout the whole cross-section.
And it's good, though, because if you're out doing the installation, you're walking around the cork, sometimes it can come apart because you want to leave a 1/4 of an inch all the way around for expansion of the floor and contraction. So the idea here is to put them staggered like bricks and then tape over the intersections where they meet. That way it holds the 4 pieces together like that. So that's a good way to keep them from not spreading apart. Because it's very important, because you're also going to be making a cut into the cork to get your cables back. You don't want that moving all over the place. You want to keep them tied to each other, but not to the surface above and not to the floor below, the subfloor. So let's talk about Environ.
Yeah, so Environ heating mat, like we mentioned previously, we have that product in 2 types. It's Environ Easy Mat and Environ Flex Roll. Flex Roll is the great product for more custom shape, odd shape coverages that needs to be done. And Environ Easy Mat is more like a blanket type coverage in larger rectangular mats that we have starting from 2x5 all the way to like 6x10 feet sizes.
The great thing about the bottom product is if you want to cover 60 square feet, you buy a 10x6 mat and you throw it out on the floor, you run the cable to the wall and you're done. You can really cover a lot of space really quickly. The product on the top is the cut and turn product. You would have to cut and turn it a few times to fill that 60 feet. So the absolute fastest product to install are those mats at the bottom. And the great thing is that if you look at the corner there, the electrical connection comes out of one of the corners. So you can turn it upside down. Oh, I'm sorry. You can turn it upside down, right side. You can rotate it around to wherever we need that cord to come out to get it closer to the wall. Remember, both of these pictures have been visited by the marketing department, and we just don't see that cord that's attached to them. But there is going to be a cord attached to each one, and you just need to make sure that you plan for that. It's very easy to do with your cork underlayment. So that's kind of like what Environ mats are. The roll at the top, we didn't mention it, but the roll at the top is 1.5 feet wide.
Yeah.
So you do cuts and turns a foot and a half by whatever length you want or you've ordered. That's the big difference between that product. So tell us about this next slide here.
So engineered wood floating, as long as we have that cork down, we have that floated, we have a heating mat down floating, and again, if it's a flex roll application, we just follow the installation plan that our engineers did, and then at the very end, as the last layer, of course, the floating wood flooring comes in. Important thing to check here is to ensure that the wood flooring you have does not have a foam or cork backing attached on the underside of the flooring, simply because that layer will act as an additional insulator. It will trap that heat. It will kind of stop that heat from transferring and going up into your floor or the room.
Right. The last thing you want to do is put cork backing above the heat or foam. Foam and cork are, once again, we talked about their insulators. So we want the insulation to be under the mat, not over it,
exactly,
to keep the heat from going into the flooring. So what you want to do is, if you're thinking about getting a specific type of engineered wood, is to ask the manufacturer, what's the R value of this plank? And they'll tell you what it is. Usually it's under 1, unless it's got a really thick cork or foam backing, and then it may go over 1. If you have the choice, you want to choose the one that has the lower R value, because that's going to allow more heat to come up to the floor. Now, we had a question from Kelly, and that is, do these big mats come in custom sizes?
Right. So yeah, the big mats, which we call Environ Easy Mats, those we have in a standard predetermined sizes. So it would typically be those large rectangular sizes. However, anytime the custom shape or, again, custom size or custom area needs to be covered, that can be achieved by using just the flex roll. It can always be done where the combination of a large mat with the flex roll will be installed, and that's a totally normal, totally standard application.
Yeah, so if you have 100 square feet that you want to cover, you buy 2 6x10s, and then you use the other product to fill the space in between them or around them. That's the fastest installation to do. So that's how you accomplish custom sizes using stock product.
Correct.
So very good question, Kelly. Thank you for submitting that. Now let's talk about glued down engineered wood.
So with a glue down engineered wood floor in our cross section here on the screen, we start with a concrete slab application, concrete slab subfloor. And since we know the concrete slab during the winter times will be cold, and that's where we want to insulate, we want to provide that thermal break even more. That's where we add in another product, Cerazorb. That's a synthetic underlayment. We're going to talk about that in just the next slide. But that's what we're adding first to create that thermal break. We're laying down a new product that we will be discussing later on here as a temp zone flex roll. That's that heating product that needs to be covered in a non-combustible medium. In our case, that's a self-leveling cement. So product is installed, product is fully covered with a self-leveling cement. When that layer is nice and dry, then the flooring installers would just come and install the flooring with the flooring adhesive of the recommended choice.
Now, the Cerazorb and the cork are 2 different sizes. They're off by 1 millimeter. The Cerazorb is 5 millimeters thick, the cork is 6. So we didn't talk about Cerazorb with the Environ product because it's a little bit too thin to let the cable go through without teeter-tottering.
Right.
Okay, so it's a little bit thinner. So if you're going to be going over a concrete slab with Environ, you definitely want cork. Otherwise, you're going to be chiseling out concrete to get the wire back to the wall without doing the teeter-totter over the cable. So that's one thing to keep in mind. So if you ever have any questions about that, you can always call us. We're more than happy to answer the question. We did get a question from James, and it says, can you install over ceramic tile? Well, yeah, you would put a product like Cerazorb or cork to get you the clearance for that cord to get back to the wall. And it would also help give you some heat directed up. But now you're talking about increased thicknesses, height of the product. So you're really going to have a major transition if you're not taking the tile out. I kind of like taking tile out because I get to use a really big hammer, and I get to use one of those things and break that stuff up. So if you're having a bad day, you might just want to go ahead and take the tile out. I don't know. Works for me. Thank you for the question, James. Next thing, let's talk a little bit more about Cerazorb.
Yeah, so some details about the Cerazorb. First of all, I would say the key difference would be that this is a fully synthetic product. That's not your regular natural cork. That's a synthetic product. product, so it's ideal for use in the areas that are prone to high humidity or moisture because it's synthetic. It doesn't promote any mold growth. And like I said previously, it's recommended for these concrete subfloors application because that's where it's really brings those main benefits, that thermal break, that R value of 1.5, which you would think it's a pretty low number, but for that given thickness of only 3/16 of an inch, that's a pretty high value. And as far as we know, that's one of the highest product on the highest R value on the market for the products of that type.
If you've ever seen any of our webinars, you know that we love this stuff because there's no reason to be heating the area below the floor. Absolutely no reason. You gain nothing by that. You want your floor that you walk on to be warm. You want something under the cable that pushes the heat upward, doesn't let it go down into the slab. And that's exactly what this does. By adding a thermal break like this, you can make the temperature, depending on the conditions of that particular day with the ambient temperature, you can make it get 4 to 8 degrees warmer using this product. It can also heat up 2 to 3 times faster. So sure. If you want something that heats faster and gets warmer, don't we all? Cerazorb or cork are what you want to get under that product to make the heat go upwards. Now let's talk about temp zone rolls.
Yeah, temp zone rolls, the product that we use for pretty much all types of flooring that just simply can be installed. Because this product, first of all, can be modified, can be cut and turned without cutting the wire, of course, but the mesh itself can be cut and turned based on an installation plan or smart plan that we are providing into really any shape, any odd heated coverage areas that needs to be done. And the thing with that product is that your main next installation step is you covering that product with the self-leveling cement or thin set in some cases. And after that, you just have a nice flat surface where really any flooring can go on top.
When you see this blue wire on a green mesh, this product has to be embedded in a non-combustible medium like self-leveling or thin set. It is not to be designed to be used out in the open air, so you wouldn't put this on a subfloor and then put laminate over the top of it.
Right.
This product needs to be covered with self-leveling or thin set. Now, if we take a look at this product, it also can be taken off of the mesh, because if you've ever seen some of our plans, they do show the wire where it gets free-formed. Free-form means you take the blue wire off of the mesh and then you glue it down using hot glue into small little irregular areas that you can reach using that. So if you take a look at this picture, you also see that black thing with the knob on the end over there in the upper right-hand corner. That's your thermostat sensor. Very, very important when you are putting a product down like hardwood, like engineered wood, anything that's a natural product like this. Usually the manufacturer will have a recommendation as to what the maximum temperature is, what the minimum temperature is, what the relative humidity is, what kind of temperature swings can happen in one day. Some companies don't even want you to change it from 85 down to 80 or from 85 to 84 or 85 to 83. They want it to stay constant the whole time, which you can do easy enough with this product. And that's kind of how you comply with a warranty. So we're working up to your answer here, Chris. I know you're sitting tight there waiting, but we're going to tell you why this product can be used with this type of wood flooring, right, and why it's actually better to use electric than it is to use hot water. But that sensor there needs to be buried in the floor, because that way we can keep track of the exact temperature of your floor and keep it usually within a half of a degree. That's 0.5 of a degree. Hot water overshoots and undershoots. So if you're really close to the side of the wall where the boiler is, that water is always going to be really hot when it comes out. But if you're at the other end of the room where it's running out and then going back to the boiler, that part of the room is going to be a lot cooler. So you have a steady temperature no matter where it is in the room, and you can keep it within a half a degree all of the time if you want to. That's what's so great about heating these hardwood floors with electricity. But you can only do it when that sensor is installed. So don't forget the sensor. Where's the sensor when you get the order?
The sensor always comes in the thermostat box. So if you order in your heating product with a controller, with all of the accessories all in the same time, sensor comes in that thermostat box. We also do offer the replacement, or what we also call it, a backup sensors that can be installed as well, just in maybe a slightly different area, just in case somebody cuts or steps or drops some heavy tool on that sensor. You have the spare one or the backup that is ready to be connected to a thermostat.
So what about these newfangled controllers, the thermostats that are Alexa or all these other brands? Is there something that you should look for if you want to heat hardwood floors, specifically with a third-party thermostat? We can integrate the third-party thermostat to our heating rolls. We have the product that bridges that gap because those products are 24 volts. Our systems are 120 or 240. You need something to get from 24 volts up to 120 or 240. We have that product that lets you do that, called an integration kit. But what should a customer look for when they're going to think about putting hardwood floors in with a Nest or with any of those other third-party thermostats?
I think the key part here is, like Scott mentioned previously, to follow those wood flooring manufacturer recommendations. And if there is a specific temperature limit that you want to stay on, you always want to have a controller that can receive a floor sensor. In other words, some standard ambient temperature controller on the market, they simply do not have a connection for the floor sensor, which means there is just no way for that thermostat to find out what's the temperature of the floor. And again, if you're planning to maintain that 80 to 85 temperature range, there's really going to be no option to do that.
So if you're thinking about doing this type of hardwood floor installation or anything that requires a temperature limit, say like carpeting, some carpet companies require that it's kept at a maximum temperature. If you're going to do that and you want to do it with a third-party controller, you need to make sure that it has an input for the floor sensor to go into. And what is the easy way to remember what makes a different sensor a different kind? Is there some rating that the customer should look for that this sensor plugs into the thermostat?
Yeah, I mean, typically when you're shopping or searching or just researching those third-party or low-voltage or home automation thermostats, what you really want to look for is, first of all, like Scott just said, if there is a connection for the floor sensor, and then find out maybe from the spec sheets or installation manuals what specific sensor type that thermostat, that controller can receive.
What number are we looking for?
We're looking for typically a 10K sensor, since it's, I would call it North America standard resistance sensor. If there is other sensors that thermostat can receive, then typically the manufacturer of that controller would provide that type of a sensor.
Very good. So let's talk about self-leveling cement. I love self-leveling cement because it's fun to put in as long as it's not 7,000 square feet. And it is really something else to work with because what you end up with, you start with these buckets of this mess and you pour it out onto the floor. What you end up with is a nice, perfectly flat surface that you're going to have. And you can put hardwood over it. You can put carpeting over it. You can put anything over this nice flat surface. You decide, hey, I have carpeting here, but I want to put floating engineered wood. Perfect. You rip up the carpet and you lay the engineered wood right on this flat surface. What else do we take a look at this?
That's a picture here that we're actually showing on that slide. That's probably like your last chance here to install that sensor that we were talking before, because once the self-leveling is poured, you pretty much no longer see where the heating the heating coils are. So you really want to make sure that sensor is installed by that time. But yeah, like we're showing it here, when the product is installed, after it's embedded in the self-leveling cement, once again, any flooring can go on top as long as it's made for that type of application. And the important step here is to ensure that the flooring will be installed after that self-leveling is completely dry.
So you see these guys come in, a concrete slab, you do new construction, they come in with this meter, they take this meter and it's got usually 2 probes, and you stick that down into the floor. What they're doing is they're doing a moisture test. Your flooring manufacturer will tell you what the maximum amount of moisture is allowed in the subfloor before the product can be put on. You just follow that instruction and you really don't have anything to worry about. What you do have to worry about with self-leveling cement and temp zone is what?
I didn't catch that question.
Well, it's Because the question's up here.
The floating of the wires, right?
Yes,
Yeah.
yes.
So whenever you pour in that self-leveling cement, you want to make sure that the product that you're installing, no matter if it's a flex roll on the picture or if it's a loose cable, that product is always nice and secured on the subfloor, so it's not floating up to the very top.
Self-leveling is very, very dense, kind of like me. And the thing is, anything that is covered by self-leveling, that product wants to go to the top because it's much less dense. So it wants to float to the top. So do we get calls from people who don't attach the product to the subfloor real well?
Unfortunately, yes, we do. Yeah. So like we show on almost all of our installation materials, installation instructions, attaching the product to the subfloor is a really critical key of the installation.
Important. And also, you notice how the cable here is installed cable side down, because if you turn it upside down, we always want the cable down in this product as much as possible. If you turn it so the cable's facing up, even if you attach the mesh really well to the subfloor, the ends do this.
Right.
The ends will go whoop, so then you have these little loops that you see the tops of in the self-leveling pour. So we're just trying to bring this up for you to save you the issues that we talk to people about, because these steps get missed. And I guess that's kind of why we're here today, is to kind of forward our information to you so you don't have any issues the first time you put it in. Now let's talk about flooring and adhesive.
Yeah, so great picture here showing you really nicely installed glue down wood flooring. But remembering the previous image, when that self-leveling cement is fully covering the whole mat, when it's nice and secure, nice and dry and secure, and it's all flat, that's when you, at this point, pretty much following the wood manufacturer instruction, spread that adhesive around, potentially working in sections, depends on how large the area is, and continue installing that wood flooring based on the manufacturer recommendations.
Yeah, the thing is, excuse me, this last bullet point kind of got away from us here. This last bullet point should read, wipe adhesive away from joints on the flooring surface as you're going. Because you don't, if you go back 3 hours later to get rid of the adhesive, it's already turned to rock. So the idea here is you're wiping away the adhesive from the joints on the flooring surface. Once again, you're just using adhesive to get the joints together. You're not gluing them down to anything. You're not gluing anything to above or below. If you're gluing the edges together, sometimes you're going to have some extra glue. Clean it as you go before it turns solid. So that's, sorry about the typo on that one right there, but we did catch it. So let's talk about nailed down hardwood. Nailed down hardwood, we get questions about this all the time. So let's take a look at the cross section.
Yeah. So the cross section, I would say, is probably the most important key element in the whole application, just to give an idea of how that can be done. Like the call I just took yesterday was from the customer who wanted to install a nailed down hardwood, but he immediately kind of backed out from that, thinking like, I'm going to damage the cable. That's not the case here, because the easiest way to install the nail down hardwood with a heated floor, with a heating element like cable or mats, would be to lay down the sleepers on top of that plywood subfloor and lay down the heating product. In our case, on this image, on this cross section, it's a floor heating cable. Lay down these floor heating cables between the sleepers, and then cover these bays that we kind of creating with the sleepers, cover those with a self-leveling cement. And then in the very end, you see where the sleepers are, you nail down your wood flooring right into the sleepers. There's, I would call it, 0 chances you're going to damage the heating cable if you just nailing that nice and carefully into the sleepers.
Now, when you're doing a nail down hardwood, when you get to the end of the room, there's going to be, since you're using an angle nailer to get in to that sleeper, you're going to run out of space for that nailer on the last few runs of wood. What normally happens is that after you're done nailing as far as you can possibly nail, you're then going to start gluing the last few pieces down. Well, it's perfect because you've got glue is going to adhere to the sleeper and adhere to the nice flat surface of the self-leveling. So that's what's so great about this. The thing to keep in mind when you're doing a cross section like this is to make sure that you put, if you look at this picture right here, is that you put a perimeter all the way around, because you need something at the end to nail into. So what else we need to look at with sleepers?
So first of all, talking about the sleepers, important part here to understand what thickness of the sleepers needs to be designed for it. And since we want to cover our heating product with about 3/8 of an inch of self-leveling cement, that would be the same exact thickness of the sleepers that you want to use. Because again, in the very end, we're trying to get a nice even surface sleepers and self-leveling cement. Also the sleeper spacing. That's what needs to be determined or recommended by your wood flooring manufacturer. They may tell you to nail it every 4 inches, every 9 inches, every 10 inches. And that's where we want to design. We want to know that information so we can design the right installation plan layout and show you where the sleepers are, where the heating product goes, and what spacing to use.
Your installation instructions sometimes will say what the nail rate is. When you see the word nail rate, that means how many inches are between each nail. So if we'll say 8-inch nail rate, 10-inch nail rate, that sort of thing. So that's kind of what you're going to look for. It's probably already in your documentation. You just need to look for that wording. So what we've done here is we also have a gap at the end of each sleeper, because no matter how well you try to plan out this laying the cable out, sometimes you might have to rearrange one or two. So you don't want to have no gap, then a gap, no gap, then a gap. Notice how on these there's a gap after each one before it reaches the right side or that side over there. So if you take a look at that, there's a gap between every single one of them. That way it allows you to rearrange if you have to. If you only stagger those gaps, you're then there with a saw trying to create a gap to get the wire because you might have to move it around. So always leave a gap at the end like that. Now, temp zone cable seems perfect for this application.
For sure. So like in the application that we're showing right here on that image, we have, I would call it a pretty tight sleeper spacing. And that's where we definitely want to use the cable because it looks like we're just doing 3 runs of the cable in every bay. And that's where the cable goes perfectly fine. In case that would be a sleeper spacing of 18 inches or more, that's another great example where we can even use our temp zone flex rolls because those are coming in 18-inch wide sizes. But yeah, when the cable is down, we want to secure that cable to the floor with a masking tape every few feet just to, again, prevent that cable from floating up. So that's an important part of the process. Of course, cable will be secured and tightened at every end of that, every side of that room where the fixing strips are. And yeah, just keep that masking tape running and ready just to make sure that the cable is not floating up on you.
Yeah, it's in theory you can use cut and turn rolls to fill this space, but these are 8-inch nail rate on this particular floor, and those are my feet there in that picture. And I'm notice how I'm not wearing hard soles, I'm not wearing steel toes, I'm wearing very soft tennis shoes because that's what you always want to do when you're working over electric heating cables. You don't want any hard soles, you don't want any steel toes. But if you look there, 8-inch nailing rate works out perfectly. So we can get 3 runs of cable in each bay. If you're doing that with cut and turn, you'd have to cut, then turn, then cut and turn. This way you just string it back and forth and it's a very quick installation. So if you're doing this, we always suggest cable. In theory, it can be done with the cut and turn rolls. If your nail rate is 18 inches, just like Anatoly said, if it's 18 inches, then fine, just roll out the product on the mesh because then it's even a faster installation. Let's talk about self-leveling cement.
So yeah, next step, like we discussed, cable is down, cable is secured, cable is covered with this masking tape every few feet. That's going to be the point where we want to pour the self-leveling cement in those bays, right in between the sleepers. And the key step here is ensure that that self-leveling cement, that level of the self-leveling cement will be exactly at the same point where your sleepers are. So in the very end, you will create a nice flat surface where the sleepers and the self-leveling cement will be on the same level. And the reason it's very important is because your base, your self-leveling cement is what actually creates the heat. That's what will be heated. So you want to make sure that self-leveling cement is in contact with your wood flooring and it's transferring as much heat as you can.
Yeah, the last thing you want is a 1/2-inch air gap between the self-leveling and the wood because that air acts like an insulator. So you don't want that. You want that self-leveling to be right up under that wood so it transfers the heat right through it. Now let's talk about installing the hardwood floor.
So from the going kind of slowly back into the previous step, when everything is poured, that's again that time when we want to ensure that the self-leveling is completely dry. Then we continue into our next phase where the wood flooring will need to be installed. Of course, important part, and I would say it's a straightforward part, we want to make sure that sleepers would be running perpendicular to the wood flooring.
So if you're sending us a plan, you need to mark on that plan, here's the fireplace, here's the doorway, here's going to the kitchen, that sort of thing. And you need to tell us which direction the wood needs to be going to match the rest of the house. The one job that I just did already had hardwood in the kitchen, and this room abutted right to it. We wanted to make sure that we followed the direction of the wood in the kitchen into the living room. You don't want to run the wood one way in the kitchen and then run it the other way in the dining room or the other area. You need to tell us which way the direction of the wood is going to go so we can make sure that the sleepers are installed the correct way.
And I would say if you have multiple installers or multiple contractors that are involved with the project, if the installers who are coming to install the wood flooring, they need to be aware that there is still a floor heating element installed between those sleepers. It's not just a part of the installation.
So we talked about the floor sensor before, but it's so important. Let's go ahead and talk about it again. What are some hints for the sensor?
So first of all, floor sensor comes with each thermostat in the box. So anytime installer is looking for one, check the box with the thermostat. All of our controllers comes with the sensor. So that's the point where we don't need to wait for an electrician to install that thermostat. We want to take that sensor out of the box, install it at the time when the heating element is installed. Then also on the image that is all the way to the left where we have a natural cork where we're using that Environ product for the floating applications. That's where you want to kind of create a small divot there in the cork to put that tip of the sensor in so it creates a nice flat surface. It doesn't create any bump for you between the heating wires.
One thing before we leave that picture is that's Photoshop magic going on with the silver mat, okay? You do not cut the mat to put the sensor in. It's just laying under the mat, and it has to be between two wires. If it sits on one wire, it's going to heat up very rapidly, and your thermostat will click on, and 30 seconds later it'll click off. Because if it's placed on the wire actually heats up much faster than the space between the wires. That's why we put the sensor between the wire. If you have just done an installation and you've done engineered wood and you've laid it out, and all of a sudden the next day you hear the thermostat going click, 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 thermostat's going to click. There's no way around it. There's a mechanical relay inside. But if you hear it clicking every 30 seconds, it tells you during your installation, you might have moved that metal looking product. It might have shifted on you. And now that sensor, even though it's embedded in a divot, may be sitting directly over a wire or directly under a wire. So that's what's very important is once you get the sensor placed with this product is to make sure that the product above it doesn't move.
Right.
So you're just going to run a piece of tape. But I just want to make sure that you don't go in there and go, okay, here's where the sensor goes. I need to cut this area out. Don't cut that area out. It's just there so we can see it.
Yeah, we just simply want to show that sensor, the actual gray part, the gray tip of the sensor, that's the actual sensing element. So it's also very important to make sure you actually put that sensor tip, kind of stretch that sensor wire and the tip at least a good 6 to 8 inches into the loop. The last thing you want to have is the sensor tip sitting on the very edge of the mat or edge of the loop or the very end of the loop where there is simply not much heat being created because there is no heating element on either side of it. So
how far does the heat travel from the wire?
Would be about inch and a half. So that's exactly the reason why we want to have that sensor sitting, the sensor tip sitting in between the wires and at least 6 to 8 inches into the loop so that heat transfer, that temperature is nice and average.
So that's why it's very, very important also to remember that you don't need to run the sensor out into the middle of the room, okay?
Right.
Because then you're going to be running it over heating cables, all this other stuff. We get a lot of calls from people who go, I placed the sensor in the middle of the room. How do I get the wire all the way back to the wall? You don't. You put the sensor 6 to 8 inches into the edge, into the heated area. So if your heated area is here, you don't want to put the sensor over here because the heat only travels 1.5 inches. So you need to make sure that sensor is within 1.5 inches of the heating system. So a couple really good hints there. We get these questions all the time.
I think I wanted to add just one little thing here, and I think that's exactly what the question that we have from Ed, that electricians will often run the sensor in the same conduit as the leads. And we don't like that. That's definitely not a good idea because the leads are high voltage wiring. The sensor is just a low voltage wire, and that's where we don't want to mix those two together because the low voltage sensor wire will get some interference potentially with it from the high voltage wiring, and the temperature that you will see on a thermostat may show you it's 90 degrees while your floor is only 60 degrees. So you don't want that interference happening. You want to make sure that those two types of wiring, the high voltage and low voltage wiring, are always separate. Either definitely not in the same conduit, but separate based on your local electrical code.
And the National Electric Code prohibits running a low voltage wire in the same conduit as a high voltage wire. So there's two reasons not to do it. It's against code, and it also will give induction to the temperature and make the temperature reading on your thermostat wrong. And then you're in trouble with a system that may never turn on or may never turn off. So that's a very good question. Thank you so much for submitting that one. So let's talk about installing the thermostat.
So thermostat installation, that's eventually going to be the last, most likely the last step of the whole installation process. We want to make sure that electrician install that in accordance with the local electrical and building codes. The thermostat have the floor protection. That's, I think, the most important part or the feature of the thermostat that we want to talk about today, because that's where all that floor temperature limitation comes into play here. Because if your manufacturer recommends to keep that floor and never overshoot the temperature above 85 degrees, that's the setting that we have on our units that you can set. Let's say if it's 85 degrees, we set it 85, and we know that thermostat will never allow the temperature of the floor to go above that limit.
So that's once again what's so much better with electricity than hot water is hot water it overshoots the temperature and then undershoots it because it boils the water, then it pumps it out, and as it pumps it out, the temperature slowly goes down, 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 and then the first water hit is going to take you over 85, and then at the end of the run, the water may be at a temperature of 81 or 82. It's on a constant up and down, up and down, up and down as it pumps. This product is kept exactly at an exact temperature. Now, your flooring manufacturer may let you set it for 82 or 83, whatever that temperature is, during the comfort cycle, and they may say, hey, it's okay to lower it to 80 or to 79 at night when no one sits on it or walks on it. Some manufacturers may say it has to stay at 80 degrees all the time, or it has to stay at 82 degrees all the time. That's fine. This thermostat will keep it exactly at that temperature. What you have to watch out for is the beginning of the year and the end of the heating season, because at the beginning of the season, your floor may be 68 degrees, and you may want it to get to 80. Well, you just don't on one day go, okay, I'm going to go from 68 to 80. No, you go the first day, you go 68 to 70. Next day, you go from 70 to 72, because the manufacturer may tell you what the maximum temperature deviation can be per day. So every 24 hours, your floor can deviate this much, 2 degrees, 3 degrees, whatever that is. So that tells you at the beginning of the season, 2 degrees one day, wait till the next day, 2 more degrees. And at the end of the thing, at the end of the heating season, is exactly the same. 80 to 78, the next day from 78 to 76, and so on until it's completely turned off. So those are going to be specified by your flooring manufacturer. So always check that out, because it's better to know this in advance, because we can tell you exactly how to comply with their requirements.
And I think the one part that, since we're comparing different heating types, different heating sources here, one part that I just want to mention is that electric floor heating distributes the heat completely evenly. I think I never saw a thermal picture of the floor that would have like 60 degrees there and 80 degrees in another corner, simply because if we take a temp zone flex roll as an example, it produces 15 watts per square foot in that every square foot of the mat, in every section of the mat. So
every section of the mat is going to heat exactly the same.
Would be exactly the same temperature, so there's really no going to be deviation like you compare it, for example, with the hydronic systems.
Right. So any questions? Now is a good time to put them in there. And I see we have a question from George. George, I can't address your question. We'll have to do that offline, asking about the cost per square foot of each time. This is pretty much a technical how-to video or webinar about things you need to look for during installation and operation, costs and that sort of stuff. We can get that information to you, and that's a very easy thing to do. So we will do that offline after the webinar is over, but thanks for asking, and there are differences. So we'll get you what those differences are. So thank you for that. Chris, we're going to be getting to your question in a second, but we have a couple other that beat you in first. So I'm going to go ahead and address those. Can 3/4 inch hardwood floor be nailed over the coil system?
And the answer for that is yes.
If you have been listening or stayed awake for the first part of the webinar, you would know the answer to that is yes. 3/4 inch is a very typical hardwood installation, and it works very well. Wood manufacturers, will they warrant their product with this product? Well, we've already talked about that quite a bit too. They will tell you what the maximum and minimum temperatures can be. They will say whether the heat can be embedded or not. If you see the magic word embedded, that means some sort of heating type, either water or electricity, in a layer of concrete, which is what self-leveling is. So our product is embedded in self-leveling. So it will do that. You just need to ask them. Some companies say no radiant heating at all because we're from the 1950s and we don't even know what radiant heating is. And some will go, yeah, we've tested it out. It works great. There's no problems. The best thing is you can keep the floor at the same temperature your entire day long, not depending on what the air temperature is. If you didn't have floor heat under your hardwood, I have my heat set at 59 degrees at night. Then during the day, it's at 68 degrees. So there's an 11, what is that? That's 9-degree temperature swing that my flooring in my house puts up with every day, 9 degrees. The thing is, that has no heat under the floor. But if you heat our product, put our product under hardwood, you can keep it exactly the same temperature every hour of the day. There is no expansion and contraction because it just stays where it is. So look for warranted with radiant heat. That's all you need to do, and then see if it's embedded or not, and that'll tell you what type of heat you're going to use. Embedded is the temp zone product in self-leveling. The other product is Environ, directly in contact with the floating product. Just see what your manufacturer recommends, and whatever they say, we can comply with. Usually much better than hot water. So the next one we got, I hope that answered your question, Chris. I hate, this is a question now, it's not me saying it. I hate a spongy feel to a wood floor. How can one avoid this without using too thick material for optimum heat transfer? Well, once again, I think we covered that in our presentation. You get a nice firm floor because you've got wood sleepers and you've got self-leveling. Both of them are very, very solid. That floor is going to feel very solid. There's not going to be any bouncing around. There's not going to be any of this stuff going on, as long as your subfloor is in good condition. So, question we got was, I always thought wood floors were too susceptible to temperature changes for this. I'm sure you're covering this, but why does this work without damaging the floor? Can you add anything after my diatribe there?
Yeah, like we discussed previously, the thermostats are designed to accommodate that temperature limit. So like we mentioned in this before, if there are some specific requirements, if there are some specific temperature limits that the floor needs to stay with, it's extremely easy now to set on the new units that we have, where you simply set your maximum temperature limit and your lower temperature limit, and the floor just stays between those limits based on the schedule or settings that you set for the thermostat.
Great. So how specific with measurements do we need to submit when ordering?
So typically we just want to have the dimensions of the room, dimensions or specifications of the exactly heated area that you want to add. Thermostat location is a very important part because we want to know where the heating mat will start, so the connection will be done as easy as possible. And like we discussed previously on the few slides before, air vents or any permanent fixtures, that's what you want to mark on the plan, so we know and we'll provide the layout that will go around those fixtures.
Right. Very, very important, because if you give us bad dimensions, you're not going to get a good installation plan. And when you start dealing with sleepers in a certain amount of floor, how many inches apart they are. If those measurements are all off, you may have too much cable or you may have not enough cable.
Right.
So what's good about using the cable product with our installation plan is the cable product has a white mark on the middle of the cable at the halfway point. And then every foot counts down. So if you're at the halfway point, it says 40, the next foot will say 39, 38, 37. So you know exactly where you are. If the plan says you're supposed to be here at the halfway point and you're all the way over here at the halfway point, you know that you may not have gotten those dimensions right. So whenever you get an installation plan from us, the most important thing before you even order the product is that you make sure the dimensions that we supplied on the plan exactly match the dimensions in your space. Very, very important. And next question is, can this floor heating be used on existing hardwood floors?
And unfortunately, the answer for this is no, simply because the product we're discussing today is meant to be used with the new floor installation, where the product actually goes under that wood flooring when the new flooring is being put in.
Okay, so we have a couple of questions that have come in here. Our number one is, our floor sensor details spelled out in the manual? Yes, it's on the mats. It's everywhere, because we don't want people to forget to put the installation sensor in at the wrong point of installation. So we are one of those things where, you know, that's the number one question we have here. We get the question all the time, and you have to do it. Yes. So the details about the sensor are addressed multiple times in the installation manual. We're just saying it here because when you're taking that thermostat and going, oh, this looks great, I'll get to it later. Let's put the floor in and let's cover it with self-leveling. You have to go, wait a second. I need to get that sensor out of the box and put it in the floor, then cover it with self-leveling. So are you going to cover use outside as shown in the webinar intro? That's just kind of like all of our products, Mary. Thank you for the question. Talking about snow melting, that sort of stuff. This webinar is specifically about heating hardwood. So we have lots of webinars already on WarmlyYours.com that show how to do snow melting, that show how to do tire track coverage for snow melting. There's at least 2 or 3 videos in our video section. Go to WarmlyYours.com and look for videos, and you'll see a bunch of them. One of our videos has over how many hits?
1 million just on our YouTube platform.
Yeah, so that's all about snow melt. So thank you for the question, Mary. And to answer your question, we're not going to cover it here, but we have zillions of minutes of that coverage on our website. So nailed down method, what provides a vapor barrier? If used, won't you lose sight of the sleepers? Thank you, Andy. The nail down, first of all, you need to ask your manufacturer if it's allowed on grade, below grade, or above grade. Because if you're thinking about putting a nail down wood floor in a basement, odds are that the manufacturer is not going to say it's okay in a subgrade installation. Usually if you want to put wood below grade, it's going to be an engineered wood product, not solid wood. So you're not going to be doing any nailing down. But that's a great question, Andy. Thank you so much for that. If they actually require a vapor barrier above, if it's on grade or above, really the vapor barrier should probably be put down, if you can, below the system.
That's the very first layer.
The very first layer, right. So if that's the case, then we would we need to talk about how do you get the sleepers to adhere? Do you have to seal them? That sort of stuff. That can be addressed. But if you put it over the top, just like you say, Andy, you might not see where the sleepers are. So that is going to be up to you, depending on where it's installed and what type of vapor barrier is requested or required. So thank you. And what is the lowest amount of voltage recommended? And that's from Tadra. And Tadra, our systems indoors are 120 volts or 240 volts.
Right. And probably maybe to just clarify and give additional information here, the way that thermostats operate, they always provide a constant line voltage. So if it's a 120 volt system, it's being supplied with a 120 volt, and the thermostat just cycles that power just like your light switch does, on and off to maintain a specific temperature that you set on the unit.
Yeah, for you scientists out there, that's called duty cycle. It doesn't change it from 60 volts to 120 volts to 80 volts up and down. All it does is it turns it on for a while and turns it off for a while. If our flooring requires 120 volts, can I just send a 240 volt circuit to the thermostat and have it convert it from 240 to 120?
Thermostat does not provide any conversion. So once again, it's a line voltage thermostat. It will whatever voltage it receives, that's exactly the same voltage it will send out to the heating mat. So very important to find out what voltages may be needed or required by your electrician, or if you don't have those preferences, we will design and we'll provide that voltage on our installation plan, electrical plan, and quotation information. So that would be the voltage that electrician will need to supply in the very end.
My heating product has a yellow and a black cold lead. What voltage does that take?
That's a great question, and that's a perfect color coding that we have on our products, where the yellow and black would mean it's a 120 volt product, and the red and black conductors would mean it's a 240 volt product. So it should be fairly easy for electrician to pretty much figure out what voltage needs to be supplied, even without any documentation, if that's maybe not sent or not or lost or something.
Well, let's say that my installation is a really large installation. It's like, it requires 2 mats or 2 cables. One of the cables is yellow and black, and one of them is red and black, and they hook up to the same thermostat. Is that a problem?
That would be a red flag right here. So yeah, never mix the 120 and 240 volt product together, because your thermostat will send one or the other voltage, and if it's a 240 volt that the thermostat supplies, you don't want to have that going into your 120 volt mat.
And you have to keep in mind the product on the heating rolls, the green mesh is spaced so it yields 15 watts per square foot. The thermostats only can switch 15 amps. So if you need more, if you have to cover more square footage, let's say you have to cover 180 square feet, that's where you would move to 240 instead of 120. If you're doing a small job that's only 80 square feet, you don't need to use 240. There's no benefit in using 240 over 120. Just get 120. But if you want to do big areas, that's over 220 square feet or so. That's where you're going to want to invest in 240 volts, because the thermostat will switch automatically. 120 is, remember, a thermostat's a switch. Whatever you send into it, it's going to send out. That's all it is. It just turns on and off, on and off, on and off. So there's no conversion or anything. So once again, a thermostat will not convert 240 to 120. It will not do that. If you send it 240, it will send out 240. Very important to remember that.
Should we resolve the biggest myth in the floor heating, that 120 volt and 240 volt systems, they work in at exactly the same performance level, it's exactly the same efficiency or economy, these totally same systems. There is no benefits. 240 will not heat faster than 120.
Okay, so we have a couple more questions. And can we install 2 layers of Ceresorb to raise the R value to 3 for basement concrete? In theory, yes. I would have to ask Ceresorb. The manufacturer is Impacta, is the name of the company that makes Ceresorb. I believe if you wanted to do that, once again, we're not here to sell you everything in the world. There may be Ceresorb at thicker product thicknesses. But to be honest with you, we've been selling this stuff for years and have never heard of anybody doubling up, because all, once again, you're doing is you're just creating a thermal break between the wire and the cement. That's going to keep it from going down. You don't want to lay the heat on the cement, but any kind of R value you can get between the cement and the heating cable is going to instantly isolate it below. So I can tell you honestly, I've never heard of anybody doing that, because I don't think you've had to, Ed. That's a great question.
That's exactly what I wanted to say. At this point, we're not really looking into some high R value numbers, just like you would see in traditional house insulation. We're just trying to create that thermal break and provide that separation.
If you're installing this product over an unheated area, an unheated crawl space, or an unheated basement, then it might behoove you to actually put some insulation in the joists below your floor, because that will give you the R19 or the R12 or whatever you want under there. But once again, all we're talking about is isolating the wire from the slab. So if you want to maximize your heat and you're over an unheated garage, if you're over a crawl space that's unheated, then go ahead and put some R19 or whatever your code will allow under there. Anything you can do to keep the heat from going to a colder location, other than your feet. So we'd like to thank everybody for all the questions today. It's been a great webinar. And we appreciate you following along with us. Probably the most questions we've ever had in one of our webinars. So
sure.
We had some people that were interested in this. So let's talk about our next webinar, and that's the spot heating, the secret to affordable floor heating. And that's on Thursday, February 8th at 1 p.m. So let's talk about our monthly promotion. What's the monthly promotion? It's January, right?
It's still January, and we're still running the 25% off of all of our towel warmers, and it's starting January 1st, which already started, right?
Yep. Mm-hmm.
And it's ending January 31st.
So visit warmlyyours.com to learn more about that. And we also value your feedback. You'll receive an email shortly about your experience with this webinar today. We will be sending you a copy of the webinar, and then this webinar will be posted on our webpage. So Tadra, thank you for asking that. So you can send that to your installers and get them informed with that. And then if they have any questions, they can just give us a call whenever they feel like it. We'll be glad to go over with it. So please let us know your feedback. If you thought it was too long, if you thought it was too short, I mean, it definitely went longer than we planned because we had so many questions, but that's a great problem to have.
Oh, yeah.
So thank you for that. And we appreciate your comments and suggestions, anything you can give us with that. You can contact us at 800-875-5285. You can email us. The president of the company, her name is Julia Billen, and her email address is jbillen@warmlyyours.com. Or you can send us an email anytime at info@warmlyyours.com. And once again, our web address is there. I don't need to say it. We're also on Facebook, so please like us there. And until next time, stay warm and
be radiant.
Thanks for watching.